Hello, dear students. Today we are going to discuss some more important questions on limits, and this will be part 2 of lecture 2 on limits. And in the previous video we did a few questions on limits having one correct option. So today we are going to discuss some more questions. Okay, and these are the questions are selected from some very good books. So I hope this will definitely help you for your preparation for entrance boards or other exams like KVPY, etc. Okay, so we are going to discuss, this will be the first question. In the previous video we did up to question 6, so we'll be starting from question 7 now. Okay, this is the questions. We need to find the limit n tend to infinity n square x into 1 by n minus x to the power 1 by n plus 1. Okay, let's start. We'll just write these questions. Limit n tend to infinity n square x 1 upon n minus x to the power 1 upon n plus 1. Right? So let us check the form of the limits. If you substitute n is equal to infinity, so it is n squared. This is infinity, and if you substitute n is equal to infinity, this is 1 by infinity 0. That is x to the power 0 is equal to 1. Similarly, this is also 1. So 1 minus 1 0. So this is infinity into 0 form. Okay. Now what to do this? So we can just proceed these questions in this way. Okay, n squared. From this expression, okay, x to the power 1 upon n plus 1, we are going to take this term common. Okay, this is 1 upon n plus 1, x to the power 1 upon n plus 1, that term we are taking common. So this will be x to the power 1 by n, and since from this expression also we have taken x by 1 upon n plus 1 common, so this will be multiplied by x upon 1 minus 1 by n plus 1. Okay, and this will be minus 1. Done. This is step 1. So what's the next step? Limit n tend to infinity. So just get the logic, like what's the reason that we need to take this particular term common. Okay, I'll explain that point also. So n squared into x to the power 1 upon n plus 1. Okay, so it's just going to simplify these expressions. So they make a common base, so just take x, so it's 1 by n, okay, 1 by n, and this is plus and minus 1 n plus 1, done. So you can just add the exponent and minus 1. So this is the term after taking common x to the power 1 by n plus 1. So let's see the next term. Okay, so what will be the next term? Okay, these are the options, so we'll just leave the options there. Okay, we can just move to the steps after this. Limit n tend to infinity. Okay, let these terms be there, that is n squared x 1 upon n plus 1, let it be there. So I'm just going to focus more on this particular term. Okay, this is x. Right, we'll take LCM, this is n plus 1. If we take LCM, this will be n plus 1 minus n. N plus 1 minus 1, so n cancel out. So it gets only 1, right? It's minus 1. So it's got this term after simplification of this. Okay, now let's move to the next steps. So maybe you have now the idea like what's the reason that we have taken this term common. So just at the same time, I'll just write one limit, one important limit. This one explained in the previous classes, that is x to the power 0. Okay, just we have one important rule in limits, that is limit x tends to 0, a to the power x minus 1 x. Now please compare this expression with this. Okay, so what is this value of this? Limit x tends to 0, a to the power x minus 1 by x is equal to log a to this e. So we're just going to use this formula. Okay, how can you use this? So this is limit n tend to infinity, so it's n squared. Okay, x 1 upon n plus 1, right? So what I'm going to do is, we're just going to manipulate one expression, that is x to the power 1 upon n by n plus 1 minus 1. Okay, what is the exponent of x? This is 1 upon n into n plus 1. That term we are just going to write this, that is 1 upon n plus 1, right? So in case like in a denominator you introduce a term like 1 upon n into n plus 1, the same time you need to multiply this, right? Right? So you are dividing this denominator 1 by n into n plus 1, so same time I'm just multiplying this. Okay? Yes. So let's move to the next expressions. What will be the next terms? Okay? Limit n tend to infinity. Okay, this is n square. This n square, this is going to use this n square with the help of this term that is n into n plus 1. Okay, this one we had to write only because of introduction of this 1 by n plus n into n plus 1 term. Okay, so we'll just do one thing, that we'll club this term n square and n into n plus 1. For this term, okay, see x to the power, in fact here we can take the limit also for this term n plus 1. Okay, now right, so what's the next expression? This is x to the power 1 upon n into n plus 1, right? This is minus 1, and assuming that if you compare this expression, what is x? A to the power x. Here also you can think of this is x, right? X is 1 upon n plus n, 1 upon n into n plus 1. I'm just going to write 1 upon n into n plus 1, right? Okay, I'll just put a bracket on this, right? Okay, so what's the next expression? Next expression is here, this is n into n plus 1, this expression is there, and this n square will be writing this side, right? Okay, now if we just compare limit n tend to infinity, this we'll just focus on this term, especially this term, okay? Limit n tend to infinity. For let's see what happens to these terms if you take limit n tend to infinity. If n tend to infinity, this term will be approaches to 0. 1 upon n into n plus 1, this term will be approaches to 0, minus 1, and this term will also approaches to 0. Exactly similar to this, limit a to the power x minus 1 by x, where x is approaches to 0. So what is the value of this? This value of this is x, log x to the base e. So definitely this limits, with this expression you can use this particular formula. Okay, I'll just write the next term. What will be the next term? Next term is this. Okay, if we take, okay, this is 1. So if we take limit on this term, only this terms, so limit n tend to infinity, so 1 upon infinity, that means this will be x to the power 0, x to the power 0 will be 1. So just, if we take limit, this will become 1. So, and with the help of this limit and these expressions, we can use log base. What is the base? Log base means x here. Okay, here base is a and here base is x. So you can just write log x to the base e. Done. So you have taken limit on this. This is 1, and limit n tend to infinity. So we are using this limit, this particular expression, like this. Limit x tends to 0, a to the power x minus 1 upon x is equal to log x to the base e. Okay, right. Now what is left out? Only left out is this n square. And if we will divide these expressions, okay, if we divide this expression, it will be, okay, if we take limit on this expression, n tend to infinity. In fact, you can directly take the limit, so I'll just write one extra term, limit n tend to infinity. If I divide both numerator and denominator by n square, this will be 1, and this will be 1 plus 1 by n. Done? Because this is, if you multiply, this will be n square plus n, and if you divide both numerator and denominator by n square, so this will be 1, and this will be 1 plus 1 by n. Now in case if we take limit, so limit n tend to infinity, so 1 by infinity, this will be 0. In fact, this will give you only 1. So answer is log x to the base e. Okay, log x to the base e. So initially I wrote one option. So if you check this, one option is there, that is log x to the base e, that options. Initially I wrote along with the questions, so please check that. That will be your options, that is log x to the base e will be the correct options out of the 4 options. Okay, now let's move to the next question. Okay, what is the next questions? This is question number 8. Okay, what is the questions? Limit x tends to 0. Okay, this is GIF, that is graded integer value function. Okay, this limit x tends to 0. Okay, 100x by sin x graded integer value functions plus 99 sin x by x, that is, this is also, that is GIF graded integer function. Okay, that 99 sin x by x is equal to these values. Okay, 199, 198, this is 0 or none of this. Right? These are the 4 options. Let's try this. Simple questions. only before that I'll just repeat one concept. Limit x tends to 0 sin x by x. Okay, limit x tends to 0 sin x by x is approaches to 1 minus. Means is the value will be approaching to 1, okay, and the value will be approaching to 1, then the value will be slightly less than 1, okay, for limit x tends to 0 sin x by x. So we know this, we are going to use this particular concept for this. Okay, let's write these expressions like this, limit x tends to 0, okay, this we can just write this 100 sin x by, okay, this is 100 sin x by x. You can just write this expression like this. Plus, you can take limit on this, limit x tends to 0. Okay, this is, you can just leave like that. Sin x by x. You can just leave like this expressions. Sin x, done. Okay, just and instead of writing x by sin x, you can just write in sin x by x. In fact, you can solve these sums in the pattern of x by sin x also. Okay, limit x tends to 0, this is sin x by x is equal to 1 minus. That means value will be approaching to 1 and will be very, very close to 1, but it will be slightly less than 1. Okay, now let us check that. So for x approaches to 0, sin x by x, if it is approaches to 1 but slightly less than 1, for example, that if we in place of limit x tends to 0, sin x by x, okay, and this value if we substitute here like 0.999 etc. like that, this value, that means this greatest integer value functions, okay, this value, in fact 100 divided by sin x by x, the value will lie between 100 and 101, right? This will be in fact very, very close to 100 and in between 100 and 101. So in case, like for example, if the value comes like the value, okay, after taking this limit on sin x by x, the value, if it comes like 100,001, for example, then what will be the greatest integer value function of this? It will be obviously 100. Okay, so let's move to the next limits. Okay, sin x by x. Sin x by x will also be approaching to 1, but slightly less than 1. So in case, in place of it's 99 and sin x by x, if you just take the value like 999 etc. like that. So, and in case if you multiply this one, so this value will lie between 98 to 99. In fact, it will be, the pattern of this value will be 98.999 depending on the value you select for this limit x tends to 0 sin x by x. So in fact, this value, okay, this value 99 sin x by x will lie between 98 to 99. So that will be a fraction, and in case if you take the greatest integer value functions, so you are going to get 98. Okay. So for example 98, if you get the form of the number like that's 98.999, so you are going to get 98, right? So hence the value of this limit is 198. So this will be your correct option. Okay. Now let's move to the next question. What is the next question? Okay. See the pattern. So limit x tends to -1, x to the power 4 plus x square plus x plus 1 upon x square minus x plus 1 to the power 1 minus cos x plus 1 upon x plus 1 whole square. Okay. Now how to find this limits? Okay, just you can find this. It's not difficult. Simple questions. Limit x tends to -1. Let me write once the question x square minus x plus 1, okay, x to the power 4 plus x square plus x plus 1, then x to the power 4 plus x square plus x plus 1 to the power, what is the value? That 1 minus cos x plus 1 divided by x plus 1 whole square, right? Okay, now check this base, like for x approaches to -1, okay? For x approaches to -1, this will be +1, and this is also +1, and this is already 1. So you're going to get 3 here, okay? So you are going to get 3 here in the denominator. Now, okay, let's check the numerator. For x approaches to -1, this will be 1, and this will be 1. And this x is going to give you -1. So this 2 value will get cancelled out. So we are going to get 2. That means for x approaches to -1, this base is approaches to 2 by 3. This base will be approaching to 2 by 3. Okay. So now check this the exponent. For x approaches to minus 1, this will be 0. So cos 0 is 1. So 1 minus 1, this will be 0. And for x approaches to minus 1, this will be also 0. So this is given by the exponent is in the form of 0 by 0. So we have to reduce. This is an indeterminate form. So we have to reduce this 0 by 0 form. So how can you do that? Okay. Well, just take limit x tends to minus 1. Okay. This is x squared minus x plus 1. This is x4 plus x2 plus x plus 1. Then you can take limit on this. Limit x tends to minus 1. Okay, this is x plus 1, 2. Okay, so we'll just use the formula 1 minus cos x plus 1, that is 2 sine squared x plus 1 by 2. Okay, so we are using the formula which trying to remove the 0 by 0 form, that's all. Okay, so let's move to the next steps. Okay, these are the options. I'll just leave the options here. Okay, 1, this is 2 by 3 to the power half, and this is 3 by 2 to the power half. The fourth option is c to the power half. Okay, let's proceed. Limit x tends to minus 1. Okay, so you can take the limit on this. I'll just take the limit together. So x to the power 4 plus x squared plus x plus 1. Done. Now this is x plus, this is sine squared x plus 1 by 2. So denominator you can just write in this way. This is option 1 is 1. I'm just going to write options 1 is 1 here. Okay. So just write this expression as sine squared x plus 1 by 2. So denominator. Okay, this 2 is there. Let me write 2 there only. So this x plus 1 by 2. I'm just going to write square to 4, and limit is there, of course. Limit x tends to minus 1. Okay, x tends to minus 1. Now, okay, let's see. Okay, this is sine square x plus 1 by 2. This is x plus 1 by 2 whole square. Why I have written 4? Because this is, I am introducing a 4 in the denominator of x plus 1. It is 2 square 4, so I need to multiply by 4. So I can take the limit now, because we are going to use this formula. So limit x tends to 0 sine is by x. We are going to use this theorem now. Okay. Now if we take this limit, this one already have discussed. This is 2 by 3. Okay. Just we are going to 2 by 3. Now if we take limit x approaches to minus 1. Okay, minus 1. So sine square x plus 1 by 2, x plus 1 by 2 whole square. This will give you, this expression will give you 1. Right? This is 1, and what is left out? It's left out is 2 by 4. Because limit x approaches to 0, sin x by x equal to, okay, 1. Right? This is 1, so 2 by 4. So it's equal to 2 by 3 and half. 2 by 3 half. So this is the correct options. 2 by 3 to the power half. Okay, simple questions is here. Only this base was very, very simple. Only there was one indeterminate form in the exponent. We try to remove the indeterminate form, and the moment we get the form of sine square x plus 1 by 2, since it is square form, so this also has to be in square form, x plus 1 whole square, and since you are introducing 2 square, you need to multiply by 4. So this gives you 1, and 2 by 4 left out, it's 2 by 3 to the power half. Okay, now we'll just move to next question. What is the next question? That is limit x tends to 0. This is a common question, important and a common question. Let's see the indeterminate form. For x approaches to 0, so this is 0, and it's already there. This is 0 by 0 form. Okay, it's 0 by 0 form. That's what are the options? These are the 4 options. Let's see how to solve these questions. Okay, and limit x tends to 0. Now, I just one request that you keep solving, alright, you keep solving along with me, and you can just pause the video and you keep solving and you keep comparing answers, and definitely you will enjoy. Maybe you can just quickly solve the sums. Maybe you have done this sum. Okay, so there will be some questions which are very, very important and common in almost in all the books. Okay, limit x tends to 0. Okay, this is x squared. What I am going to do is, okay, I'll just multiply both. Let me write these terms. 1 minus cos x, cos twice x. So I'm just going to multiply both numerator and denominator by 1 plus cos x cos twice x. I'm just going to multiply these terms. So 1 plus cos x cos twice x, right? Just multiplying both numerator and denominator by this. Now start simplifying now, okay? Limit x tends to 0. This approach is very common, and generally when irrational terms are there, we'll just try to rationalize the terms. X squared 1 plus cos x cos twice x. Okay, this is a minus b, n plus b formula, so it's a squared minus b squared. This is cos square x, and third will be removed. If you square it, this will be cos squared twice x. Done, right? So it's a square minus this will be, no, it will be only cos twice x, not cos squared. This will be cos twice x, because root cos twice x into root cos twice x is only cos twice x. Done? Yeah. Let us not try anything with the denominator now, right? So let us focus on the numerator, because still it is in the form 0 by 0. Okay, let's move ahead. What will be the next step? So for the next steps, what you can do is, you can just focus on this, because the moment you get cos twice x, so naturally that we are going to use the formula for cos twice x, that is limit x approaches to 0, right? X squared 1 plus cos x cos twice x, right? Just keep writing. Okay, then 1 minus, this is 1 minus cos square x. So this cos twice, we are going to use the formula cos 2 cos square x minus 1. Done? Okay. So let's move ahead. So limit x approaches to 0. Okay. This is x squared 1 plus cos x cos twice x. Okay. So it's 1 minus, right? We'll just multiply this. 1 minus 2 cos to the power 4x. Then minus minus plus. This is plus cos square x. Then this is 1 minus 2 cos to the power 4x plus cos square x. Okay. So what's the next term? So next term you can just write in this way. Like limit x tends to 0. X squared. Okay. 1 plus cos x cos twice x. So this cos square x we are converting to sin square x now, right? We are going to convert to sin square x. So cos square x means 1 minus sin square x. So that one and this one are just going to write 2, because cos square x is 1 minus that one and 1, just 2. And here 2 cos to the power 4x is there. Okay, this cos to the power 4x is there, and plus, okay, plus here 1 minus sin, so right, so here the cos square x, so sin square x will be left out. Then this is minus sin square x. So what we have done is cos square x, I have just written as 1 minus sin square x, and this one I have added, I got 2, right? So 2 minus 2 cos to the power 4x and minus sin square x. So let's write the next term now. What is our next term? Okay, next term will be limit x tends to 0. This is x squared 1 plus cos x cos twice x. Okay, cos x cos twice x, and you can just take 2 common there. If you take 2 common, it will be 1 minus cos to the power 4 minus sin square x. Right. Okay. Yeah. So let's write the next term. Right. Okay. X tends to 0. Okay. X squared 1 plus cos x cos twice x. This is 1 minus cos to the power 4x. So 1 minus cos to the power 4x is 1 minus cos square x and 1 plus cos square x. Done. 1 minus cos square x and 1 plus cos square x, because 1 minus cos to the power 4x, a square minus b square formula, 1 minus cos square x into 1 plus cos square x minus sin square x. Okay, just most important term is x squared. In fact, this term we have just kept writing. Okay, now let's write this limit x tends to 0. squared, 1 plus cos x, cos twice x. Okay, this is 1 minus cos square x means sin square x. So obviously you can take sin square x common. So if you take sin square x common, right, sin square for 1 minus cos square x means this is sin square x. So this sin square x and this sin square x you have taken common. So what will be left out? Here 2 will be left out and 1 plus cos square x. You can multiply by 2. So it will be 2 plus 2 cos square x, right? So you have taken from here 1 minus cos, the sin square you have taken from here, it will be minus 1. Why? Because from here you have taken sin square x, here 2 into 1 plus cos square x will be left out. So 2 into 1 plus cos square x means 2 plus 2 cos square x, and here sin square you have taken common, so it's minus 1. Done. Most important expression for this question is sin square x by x. The moment you get sin square x by x square, so if we obviously you'll be using this form theorem, limit x tends to 0, sin x by x. Okay, and that is the most important part of these questions. Okay, and it has got little simplifications, but the question is very simple. Okay, but you need to write this many, at least this many steps to find the answers. Okay, let us try the next steps now. What is the next steps? So it's just going to take a limit now, right? So if we take limit, so limit x approaches 0, this will be equal to 1. Okay, and this will be 2. 2 minus 1 is 1, right? This is 1, and this is 1, so it's plus 2, right? Plus 2, and if you take limit on this, this is cos 0, 1, this is cos 0, 1, 1 plus 1, 2, right? Is equal to 3 by 2. I just want, important thing for this question is, like this expression, the moment you multiply these expressions, like 1 plus cos x under root cos twice x, okay, initially, instead of writing this many terms, initially you can take limit on this. Okay, because for x approaches 0, it's going to give you 2. So in that case, what the benefit you are going to get? This many terms you may not write this, but like our focus was to remove x square. So we got to got the help with the help of sin square x to remove x square. The moment you got sin square x in the numerator, so you can use this theorem, limit x tends to 0 sin square x by x square, then 0 by 0 form is removed. Then you got the value. This is 3 by 2. So your answer is 3 by 2. Okay, this is also very important questions, right? Okay, and let's see what is the next questions. Okay, right? What is the next question? This is also a very important, interesting questions. Okay, let's see that. Okay, start solving these questions yourself. Okay, what is the questions? Limit x tends to 0 log 1 plus x square plus log 1 minus x plus x square by sec x minus cos x. Before you start solving this, you check the form, like what form of this question, alright? What is the indeterminate form of these questions? Okay, please check the form and start solving. Okay, and we will be solving these questions, and after that we'll just sign off for today. And one request that, and those who have not subscribed this channel, please do subscribe my channel. And next we are going to discuss questions on limits. There will be one more video on limits based on questions that maybe entrance and KVPY, and then we'll be starting the exercise from differentiations. Okay, differentiation, then differentiability, and thereafter we'll move to integral, most important for class 12. Okay, we'll be first starting the NCERT, then we'll just move to NCERT exemplars or maybe questions from for entrance. Okay, and that's what it's my request, so that you keep getting the video. All right, and we are going to solve these questions. Maybe by this time you have done this. All right. Okay, let's see that. In case for x equals to 0, so this is 1 and this is 1, so 1 minus 1 0. So these are all zeros, right? These are all zeros. Log 1 is 0. These are all zeros. Log 1 is 0. So log 1 plus log 1. This is also 0. So it's 0 by 0 form. The form is given as 0 by 0 form. Okay. So how to remove this 0 by 0 form? Limit x tends to 0. Okay, sec x, right? This sec x you can just write in the form of what 1 by cos x, right? And let cos x be like that only. Okay, 1 minus cos x minus cos x. Now this is log a, this is log a plus log b, right? This is log a plus log b. So just we'll be using this log ab formula, right? So log ab, that is 1 plus x squared into 1 minus x plus x squared. Done? Yeah, log a into b. Now what's the next step? Limit x tends to 0. Okay, so if we take the LCM here, we're just going to get 1 minus cos square x. Done? 1 minus cos square x and multiplied by 1 by cos x. So 1 by cos x. Done. We're taking LCM on the denominator. Now we can just simplify the numerator. Okay, let's see the term where the minus is there. Minus is there on x, and here this term is 1 plus x squared. Here also this is 1 plus x squared. So this term you can just write in the form of log 1 plus x squared, right? This is 1 plus x squared. This is 1 minus x plus x squared. So we can write this term as 1 plus x squared whole square minus x squared. That means we can use here a plus b and a minus b formula. That is 1 plus x squared minus x. You can just write the pattern like that. Okay, 1 plus x squared plus x. We can simplify this expression in this form. This is 1 plus x squared minus x, 1 plus x squared plus x. So this is a minus b, a plus b. A minus b, a plus b means a square minus b square. That means 1 plus x square whole square minus x square. Done? Okay. Let's see what's the next step. The next step is limit x tends to 0. Okay. So just 1 minus cos square x. This will be sin square x. Done? And this cos x you can just write. Okay. Let me write this cos x there only. Okay. Right. 1 by cos x. Done. Now how to simplify this? So our most concern is this numerator. Okay. How to simplify this? 1 plus x squared. So we'll be using a plus b whole square formula. This is 1 plus 2x squared plus x to the power 4. 2x squared plus x to the power 4 minus x squared. Done. Okay. So what's the next? Right, let's move to the next steps. Limit x approaches to 0. Okay, this is sin square x into 1 by cos x. Okay, 1 by cos x sec x. You can just write cos x. You can write here. There are so many options for this. Okay, so this terms is not going to give you any problem on that. You can substitute the limit that for x approaches to 0. This cos x will be 1. So you can just write 1 also. But our concern is this terms, this particular expressions. This how to final limit for this expressions. Okay, this is log. Then what is the next expressions? 1 plus, right? 2x squared minus x squared. We are going to get x squared plus x to the power 4. Right. Finally, you got this terms. Next term is quite. The next step is quite interesting, right? Log. Okay, this is 1, that is x square, I will take common, 1 plus x square, right? Log 1 plus, this expression will be, okay, log 1 plus x square, and right, this is 1 plus x square, 1 plus x square. That means I have taken x square common from there. So what I am going to do is, these expressions, I am just introducing in the denominator, x square, 1 plus x square, right? So in case I manipulate the denominator by multiplying x squared 1 plus x squared, same term I need to write in the numerator, that is x squared 1 plus x squared. This term, additional term, right? Additional term I have written. And what is there in the denominator extra term? This is sin square x. Sin square x, and cos x I am writing in the numerator. Only this much is left. Okay? Yes. Now let's see this one. The limit is limit x approaches to 0. Like this is 1 plus x square 1 plus x square divided by x square 1 plus x square. So just we know there is important theorem on limit. So limit x tends to 0 log 1 plus x by x. There is an important rule in limits. Limit x approaches to 0 log 1 plus x by x. Remember this actually approaches to 0. then this give you 1, right? So since limit x equals to 0, log 1 plus x square 1 plus x square, right? For x equals to 0, so naturally this x square plus x square will approaches to 0, and this is also approaches to 0. So here in this place we can use this theorem, limit x tends to 0, log 1 plus x by x is equal to 1. Fine. Okay. Now, like the previous questions, this x squared by sine squared. For x equals to 0, x squared by sine squared x. So this will also approaches to 1. Now for x equals to 0, cos x is equal to 1, right? Now for x equals to 0, 1 plus x squared. You can, in fact, you can take the limit on 1 plus x squared. This x squared you are using with this sine squared x, and this, if you take the limit on x squared, this will be 0. So 1 plus 0 is 1. So what's left out is this. Okay, we just take the limit now. For limit x equals 0, this expressions, I just can tell you, these expressions are going to give us 1. So this is equal to 1. Okay. Now for limit x approaches to 0, x squared by sine squared. So this is also equal to 1, and this will be 1 plus 0, and this is also 1. So this is equal to 1. So there is an option, you can check this options, there is an option 1. So that the option 1 will be the correct answer for these questions. Okay, today these are the questions that we have discussed, and we'll be discussing few more questions in the next video. Okay, and with this I will sign off, and thank you so much for watching my video. Thank you.